Every software team feels the same tension. Move fast and ship features, or slow down and keep things rock solid. Push too hard and something breaks. Play it too safe and momentum disappears. Site reliability. Engineering is a way to manage that tension with clarity, not gut feel. Site reliability engineering, SRE for short, is the practice of running services by defining reliability as a measurable goal and engineering to meet it. Instead of chasing perfect uptime, teams pick targets that reflect what users actually need and use them to guide trade-offs between stability and speed. Here's the big shift compared to traditional operations. The focus moves from never go down to be reliable enough to keep users happy and spend the rest of the time improving. That sounds small, but it changes priorities, conversations, and release schedules. Why care? Because reliability is a product feature. If a checkout button lags or a photo fails to load, users don't debate internal processes, they leave. On the other hand, delaying useful features because of vague reliability fears has a real cost. SRE gives product and engineering a shared language to choose deliberately and to change direction when the data says it's time. Think of it like driving a car. The gauges, the speedometer, fuel, temperature, tell how things are going moment to moment. That's the measurement side. The speed limit sets a safe target for the road you're on. That's the reliability goal. And then there's the monthly fuel budget. Take a few detours for fun, but if the tank gets low, ease off and refuel. Those three pieces together are the mental model for SRE. Measure what matters, set a target, and use a budget to balance caution and ambition. So the simple version is, SRE ties day-to-day engineering work to user happiness with numbers that everyone agrees on. That's the foundation. Now, how does it actually work? Start with the gauges. SLIs, service level indicators. An SLI is a specific, observable measure of service behavior that mirrors the user's point of view. For an API, that could be the percentage of requests that return in under 300 milliseconds. For a video app, it might be the success rate of starting playback without buffering. The important thread is that SLIs reflect what users feel, not what internal components think. It helps to begin with the golden signals: latency, traffic, errors, and saturation. Latency is how long things take. Traffic is how many requests or users are hitting the service. Errors are requests that fail or degrade. Saturation is how close resources are to their limits: CPU, memory, database connections. Those four capture the essential health of most systems without drowning teams in metrics. The key idea is that SLIs should be measured from production, ideally from the same place users sit. Synthetic checks from outside the data center, internal telemetry from load balancers, logs that capture the end-to-end experience. When the SLI is real, the conversation moves from opinions to evidence. Now comes the speed limit. SLOs, service level objectives. An SLO is the target value for an SLI over a period of time. It might say 99.9% of image loads complete within 500 milliseconds over 28 days. Notice two parts, a threshold and a window. Together, they define what reliable enough means for this moment in the product. SLOs are not contracts with penalties. That's the function of SLAs, service level agreements, with customers. SLOs are internal goals chosen by the people running the service based on user expectations and business risk. They can be adjusted as understanding improves. A useful way to set an initial SLO is to look at current steady-state performance and set the target just below it, 1 to 5% lower. That creates headroom for normal blips without locking the team into a number that's out of reach. Over time, as the product grows and user needs change, the target can evolve. With a target in place, there's a natural question: how much unreliability is acceptable before plans change? That's where the error budget comes in. An error budget is simply the gap between perfect reliability and the SLO. If the SLO is 99.9% over 28 days, the budget is the remaining 0.1%. In a 28-day window, that's about 40 minutes. That 40 minutes is the allowance for downtime or poor performance in that period. It's not an invitation to fail. It's a way to quantify how much risk fits the current goals. Here's what actually matters. Error budgets turn vague talk about reliability into a dial that product and engineering can turn together. When the budget is healthy, ship features. When it's nearly spent, slow down, fix the causes, and earn back some safety margin. Some teams track burn rate, the pace at which the budget is being consumed. That highlights patterns. A sharp burn spike suggests an incident. A slow, steady burn hints at background errors that need attention. Alerts can use burn over multiple windows to avoid noise. Fast burn over an hour paired with sustained burn over a day. Picture it in a real service. A photo sharing app measures the percentage of image requests that load successfully in under half a second. The SLO is 99.9% over a 28-day window. That implies its monthly budget for errors and slowdowns is around 40 minutes. In week 1, only 2 minutes of errors were recorded. That's well within budget, so the team proceeds with planned releases. Midway through week 3, a database bottleneck causes an outage, and 30 minutes of the budget evaporate. With 80% of the budget consumed and days left in the window, deploys pause, and engineering time shifts toward reliability work, widening database connections, improving caching, and hardening monitoring. After the immediate fix, the team holds a blameless postmortem, identifies the bottleneck, and automates scaling to prevent the same failure mode next time. There's a quiet beauty in how a few clear numbers can align decision-making from executives to on-call engineers. The math is simple. The impact is in the shared discipline it creates. To make this sustainable, incident response matters as much as targets. On-call rotations need clear runbooks and automation for common fixes. Paging should be tied to SLO impacting symptoms, not every internal hiccup. When an incident happens, the priority is to restore service quickly and safely, then to learn. Postmortems avoid hunting for a culprit and instead map the timeline, the triggers, the contributing factors, and the action items. Automation follows the lessons. Manual, repetitive work, what SRE calls toil, gets reduced over time, freeing engineers to build. Put differently, SRE is less about heroics during outages and more about designing a system where outages are rarer, shorter, and more instructive when they happen. A few practical heuristics keep teams from overcomplicating this. When choosing SLIs, start with the user journey. What counts as success from their perspective? For an API, end-to-end success within a tight percentile, like the 99th percentile latency under a defined threshold. For a streaming service, initial play success and rebuffer rate. As telemetry matures, SLIs can be refined to match segments, free users versus premium, or critical endpoints versus optional ones. When calibrating SLOs, anchor them to what's currently achievable and the business tolerance for risk. An enterprise product supporting hospitals may lean toward 99.99% availability goals, accepting slower feature velocity. A social app may find that 99.9% balances engagement and shipping pace well. Over time, review SLOs quarterly with product and support data in hand. User complaints, churn, NPS, and observed incidents. Targets can go up or down based on evidence. As for error budgets, tie policy to action. If the budget falls below a threshold, say half remaining with weeks to go, shift work toward stability. That can mean curbing risky releases, adding test coverage, or prioritizing performance improvements. If the budget is healthy late in the window, consider pulling forward a feature launch or a safe refactor. The policy isn't meant to be punitive. It's a guardrail to protect users and the business. The most powerful aspect of SRE often shows up in how it integrates with day-to-day engineering. CI/CD pipelines can include an SLO check before production deploys, verifying that current burn rate and recent incidents don't put the service at risk. Release calendars can reference the budget to decide whether to batch changes or spread them out. Dashboards focused on SLIs become the source of truth in stand-ups and executive reviews. Product managers can weigh feature impact against reliability forecasts in planning sessions. Support teams can set expectations with customers using the same language. This is where the framework becomes a shared operating model rather than a set of metrics on a screen. There are limits and trade-offs worth acknowledging. If SLIs fail to capture the user's true pain points, the targets may drift into irrelevance. A service can hit its latency goal while users still feel slow because the interface is loading too many assets. That's a hint to pair quantitative SLIs with qualitative feedback from user research and support tickets. Error budgets also rely on transparency. In siloed organizations, there can be pressure to underreport errors or to reset windows to avoid consequences. The antidote is shared ownership across product and engineering, plus clear documentation of how the numbers are calculated. Regular reviews across teams keep the focus on learning and progress, not metrics for their own sake. Another subtlety is toil. If a team spends most of its time firefighting and manually tending systems, there's no space to improve the underlying architecture. A common guideline is to cap toil to less than half of engineer time and to track it loosely. If it creeps up, that's a signal to invest in automation or simplicity. One more engineering appreciation moment here. Designing reliability around user experience rather than internal assumptions takes humility and discipline. It's not about building the fanciest system. It's about building the least surprising one. Back to the mental picture for a second. The car analogy is helpful. Gauges, a speed limit, and a fuel budget. It breaks down in a few places. Error budgets reset every window, unlike fuel, which doesn't magically reappear each month. And the speed limit for a service is not set by a sign on the road. It moves with user expectations, competition, and business priorities. Finally, a car has one driver. Software teams have many people with different incentives. That's why the framework is as much about culture, blameless learning, shared goals, as it is about math. So, what does the whole flow look like, end to end? A service starts by choosing SLIs that mirror core user journeys. It sets SLOs that are ambitious but credible, with room for normal variance. From those, it computes an error budget for the window. As the service runs, it monitors SLIs, tracks budget burn, and makes decisions about releases, rollbacks, and reliability work. When incidents happen, it responds quickly, learns deliberately, and automates the fix. And it repeats, adjusting targets as users and the product evolve. There's a practical question that often comes up. How many SLIs and SLOs are enough? For most services, a small handful covers the majority of user experience, 1 or 2 for availability and latency, maybe 1 for correctness or freshness if data staleness matters. Too many targets dilute focus. Better to get a few right and make them visible than to track dozens that no one uses. Another is alerting. Tie alerts to SLO impacting symptoms. Paging people for CPU spikes without user impact trains teams to ignore pages. Pair a fast burn alert with a slower one to catch both sudden incidents and slow degradation. Route non-urgent signals to tickets to be handled in working hours, not at 3 a.m. Governance matters too, especially in larger organizations. Error budget policies work best when they are agreed upon in advance by product, engineering, and leadership. For example, if the budget is spent, pause feature launches except for critical fixes. Prioritize reliability until burn is back to a safe level, and review the incident in the next weekly ops meeting. Transparency keeps the policy from feeling arbitrary. It's helpful to walk through the earlier photo app example with a bit more texture. Say the app serves 100 million image requests per day. The SLI is defined as the percentage of those requests that return a complete image in under 500 milliseconds. Over a 28-day window, the SLO is 99.9%. That yields an error budget of roughly 40 minutes per window. In the first week, a small blip took 2 minutes. Development continues with 3 planned feature releases. Each change is behind a feature flag, so risky features can be disabled quickly if needed. In week 3, a regional network issue and a database connection pool misconfiguration combined to cause a 20-minute incident and a shadow of slow responses, consuming another chunk of the budget. Deploys pause. The team adds a connection pool circuit breaker, bumps a cache TTL to reduce database load, and tunes monitors to detect the specific saturation pattern earlier. A postmortem reveals that a recently added image transformation path wasn't covered in the load test. The action item is to extend load testing to include that path and to add a canary stage in the release pipeline for image-heavy traffic. By week 4, burn is stable, and smaller, low-risk changes go out while the team finishes the reliability work. The next window begins with stronger guardrails in place. There's one more real-world integration point worth underscoring: contracts and customer commitments. If a business has formal SLAs with penalties, align internal SLOs to provide a buffer. For an SLA at 99.9%, the internal SLO might be 99.95% to reduce the chance of breaching the contract. The SLO remains the engineering goal. The SLA is the promise to customers. Confusing the two makes life harder for both sides. As teams mature with SRE, the conversation often moves up a level. Instead of debating whether a single service can launch a feature, leaders look at aggregate error budgets across a product. If the most critical path, say login and checkout, is teetering, the entire initiative may slow down to protect those flows. Conversely, if core paths are healthy while a non-critical analytics service is noisy, product work can proceed while the analytics team tightens its stack. That portfolio view keeps attention where user impact is greatest. Here's what matters in the end. SRE is a commitment to making reliability an explicit part of product strategy. It replaces vague terms like stable enough with measurable targets. It replaces release anxiety with policies tied to error budgets. And it replaces blame with learning and automation. Teams ship faster not by ignoring reliability, but by understanding exactly how much room they have to take smart risks. For anyone getting started, a lightweight path works well. Pick one user-facing SLI for the most important flow. Set a modest SLO with a clear window. Calculate the error budget. Add a dashboard tile that shows burn clearly. Agree on what happens if the budget gets tight. Run that experiment for a quarter. The experience of seeing decisions improve with just those pieces is often the best motivator to expand. There's a subtle reward here. When reliability is treated as a design parameter, not an afterthought, teams can be ambitious without being reckless. That balance is what users notice. The app feels fast and dependable most of the time, and new capabilities arrive with a steady cadence. It looks like magic from the outside, but underneath it's the craft of choosing the right numbers and letting them guide the work. So, a final snapshot to carry forward. SLIs are the gauges that reflect user experience in real time. SLOs are the agreed targets that define reliable enough for a given period. Error budgets are the allowance that governs how aggressively to change the system. Track them from the user's perspective. Use them to decide what to build and when to pause. Learn from every incident and automate the lesson. If this helped, a like and subscribe helps us make more of these.